Okay, so welcome back to another video. So in today's video, this time no integrals, no series, no derivatives. Well, I don't think I've ever evaluated some derivative as part of a video, but this time this is different. So this time we're actually going to be evaluating some trig value. So we are asked to evaluate the cosine of inverse sine of 8 over 17 plus inverse cosine of 12 over 13. Okay, so there's a lot going on, but it's actually the simplification comes out really nice. So notice that our expression is actually in the form of cosine of capital X plus capital Y, where such that, let's say capital X is equal to the inverse sine of 8 over 17, and then y, capital Y, is inverse cosine of 12 divided by 13. Okay, so now what we can do now is that we want to know exactly what inverse sine of 8 over 17 and inverse cosine of 12 over 13 actually equals to exactly. So what we can do is let's actually focus on our inverse sine of 8 over 17. Okay, so inverse sine of 8 over 17. And we know that's equal to x. So let's actually take the sine of capital X. Let's actually take the sine function from both sides such that the inverse sine actually cancels out. So this means we're left with sine of capital X is equal to 8 over 17. And now notice that sine of X is actually supposed to equal to, when you're looking at your right triangles, it's the opposite over your hypotenuse. And let me actually write the same format, because this is exactly the same thing we're going to be doing for y equals inverse cosine of 12 over 13. So inverse cosine of 12 over 13 is equal to y. Then to put it simply, that means we can take the cosine of both sides. So this means cosine of capital Y is equal to 12 over 13. And we notice that cosine of y is actually equal to the adjacent over your hypotenuse. Okay, so it's actually, and then in order to find what those missing values are, so this means, let me draw out the right triangles for both of these. So 2 right triangles. They're not drawn to scale, by the way. So anyway, so let's say so 17 is supposed to be our hypotenuse, and then 8 is the opposite. So this means that x will have to be our angle over here. Capital X will have to be the angle over here, which is 8 over here. And then over here, 13 is our hypotenuse, and then we have the adjacents equal to 12. So this would have to mean that the y is our angle over here. So we have to find this missing value over here. So clearly you can see that this is, in order to find the missing sides over here, this means this is just 8 squared plus, I'll just call this lowercase y squared equals 17 squared. This is 64 plus y squared equals 289. You subtract 64 to both sides, then we get that y squared is equal to 225, and we get that that missing side is equal to 15. So this is equal to the adjacent for this. And then over here we get that, I'll just call this x squared plus 12 squared equals 13 squared. This is x squared equals or that's supposed to be a plus. I haven't gotten to the equals yet. So this is plus 144 equals 169. Subtract 144 to both sides. We get that x squared is equal to 25. When you take the square root of both sides, you get that the missing side is equal to 5, and that's supposed to be the opposite. Okay, nice. So that means, let me erase what our question mark is. And so therefore 5 is our missing length over here, and then 15 is our missing length over there. Okay, nice. Now, notice that we have, to begin with, the expressions in our form cosine of capital X plus Y. So cosine of X plus Y. Simply this is equal to our, our angle sum identity, which the formula is defined as follow, is cosine of X multiplied by cosine of Y minus sine of X multiplied by sine of Y. And this is very important as we actually found those missing sides from our triangle. That's going to be important. Okay, so reiterating, we so far have that sine of capital X is equal to 8 over 17, and then cosine of capital Y, that's equal to 12 over 13. All right, so all we have to do is we need to find our value for cosine of capital X and sine of capital Y. Okay, so that means sine of Y, so we go back to our sine of Y over here, it's opposite over hypotenuse, which sine of capital Y is simply just equal to 5 divided by 13. And then we have cosine of capital X from over here, cosine, so this is actually 15 divided by 17. So 15 divided by 17. Okay, so now the rest should be simple from here. So all we have to do is plug in our missing pieces. We just rewrite the formula again one more time. Sine of capital X and then sine of capital Y. And to put it simply, this is, where is it? Cosine of X is 15 divided by 17 multiplied by cosine of capital Y, which is just 12 divided by 13. Subtract sine of capital X, which is 8 over 17 divided by, or multiplied by sine of Y, which is 5 divided by 13. And the answer should be clear. So we have that common denominator 1713. The denominators both equal to 221. And then we just calculate the numerators. This is actually just 180. Then 8 times 5 is 40. Therefore, our final answer should come down to just 144 divided by 221. Rewrite that again. 144 divided by 221. And that is our final answer. So therefore, cosine of the inverse sine of 8 over 17 plus inverse cosine of 12 over 13 is simply just equal to 144 divided by 221. And I told you it comes down nice, didn't I?